You turn on the shower, expecting a blast of hot water, but instead you get a freezing wake-up call. You climb up into the attic to investigate, only to find your water heater sitting there completely silent. Even veteran plumbers can get tripped up here. They'll confidently replace the pilot assembly or swap out the entire gas control valve, only to find the tank is still completely dead. But the tank isn't actually broken. It intentionally shut itself down, triggered by a hidden microscopic mechanism designed to kill the system. Deep inside the combustion chamber sits the culprit, a tiny, fragile glass vial filled with a specialized oil. The intentional, violent destruction of that single piece of glass is the only thing standing between a functioning home and a catastrophic fire. To understand why this happens, we have to look at how a water heater breathes. It needs 3 strict conditions to operate safely: a steady fuel source, an ignition spark, and a constant supply of oxygen. Look at this diagram of a standard water heater. You can see how the system continuously pulls fresh oxygen from directly underneath the base of the tank, drawing it upward to feed a stable blue flame in the center. In many southern states, builders place these units up in the attic to save floor space and take advantage of the warmer ambient air for energy efficiency. But attics are often poorly ventilated. Over years of operation, they act as massive traps for heavy, dense dust and debris. That environmental dust slowly accumulates underneath the unit, eventually clogging the microscopic pathways meant to pull in fresh air. Without enough oxygen, the flame begins to suffocate. As it starves, it burns uncontrollably hot, drastically spiking the temperature inside the chamber. The dusty attic environment effectively weaponizes the machine against itself, turning a safely controlled burn into a runaway thermal threat. This is exactly why Rheem engineered the thermal release device. It acts as a highly sensitive emergency brake to stop this runaway overheating scenario. It relies on a piece of glass tubing, no bigger than a small fuse, filled with a specialized temperature-sensitive oil. As temperature drives past safe limits, the oil inside expands. The internal pressure builds until it violently shatters the surrounding glass. That brake sets off an immediate mechanical chain reaction. A tensioned rod, previously held back by the intact glass, snaps forward and instantly slams the gas valve shut. To undo this shutdown, you have to get inside the unit. This requires using a specific T20 star wrench to bypass the outer panel and pull the entire burner assembly out. Once it's open, you meticulously use a small pin to clear the tiny air intake holes of the built-up attic dust and the shattered, oily crystal fragments left behind by the broken fuse. Then comes the hard part, reaching deep into a dark, cramped attic space to manually compress that heavy safety rod down, spinning it to lock a brand new glass fuse into place. Putting it all back together reveals a clever bit of engineering for Rheem. The reassembly plate uses a magnetic gasket, snapping effortlessly into place to perfectly align and seal the heavy metal barrier without a struggle. Replacing that single component restores the exact balance between the appliance and its environment, fully rearming the analog failsafe for the future. With the system sealed, the restart sequence begins by holding down the pilot button. This manually forces any trapped air out of the line so the raw gas can flow smoothly. Hitting the igniter switch sends a sharp spark into the darkness of the sealed chamber, finally catching the pilot light. But the system won't run on just a pilot light. It requires one final, critical component, the solid copper thermocouple. In this diagram, you can see the thermoelectric effect in action. The small pilot flame physically burns directly against the copper tubing, generating a tiny microelectrical current. That heat-generated electrical charge is the exact mechanism required to hold the main gas control valve open. With the valve open, a massive influx of gas reaches the main burners, igniting the primary heating sequence and starting the 45-minute countdown until your hot shower is ready. A modern water heater is a highly tuned hybrid of fluid dynamics, thermal physics, and sacrificial failsafes, components designed to destroy themselves to keep your home safe.